Welcome back to the Scotti-BYTE channel, and this is Scott. So today we want to talk about Pi-hole in Incus. Pi-hole is an easy to implement adware and malware domain blocker, as well as a great local DNS. And not only that, it's a great starter application as the first application to implement in an Incus server because it's very easy to install. So Pi-hole is frequently implemented on a Raspberry Pi because of its low resource requirements. And if you watch my Incus Containers step-by-step tutorial, we learned how to configure an Ubuntu server with Incus. And so this would be our first application that we would put inside of Incus. So this time we're leveraging the bridge profile we created in Incus, and we're creating an Incus container for Pi-hole. So here we are at a terminal on our Incus server, and you'll recall from last time that we had one container left over at the end of the Incus step-by-step video. And if we do an Incus list, there's that container named second. So we want to create another container, and this time we're going to create this container for Pi-hole. So I'm going to go ahead and name this container Pi-hole, and I'm going to do an Incus launch, which goes ahead and creates the container and starts it. And then I'm going to say images Ubuntu 2204, and the name of the container will be pi-hole. And then we're using the default profile, which tells it to get its storage out of the default pool. And then I'm using the bridge profile, which tells it to bridge it to the main LAN through our bridge 0 switch that we created last time in Incus step-by-step. And finally, I'm saying boot.autostart equals to true, which means that every time this Incus server boots, that this container named Pi-hole will start automatically. So once I've hit enter, it goes ahead and launches that new container, and I should be able to do an Incus list, and there's the new container, and we just have to wait a short period of time, and it will be assigned an address on the main LAN from my DHCP server that is running on my router. So we do another Incus list, and we still are waiting, and sometimes this takes just a little bit of time before you'll actually see an address come back, and part of that is just how long it takes. So we do it again, and there we are. Pi-hole is running, and it also has an address on the main LAN of 172.16.1.169, which is in my DHCP scope for my main LAN. Let's go log into the root account for our new Pi-hole container, and in order to do that, we're going to do an Incus shell pi-hole. The first thing you should do after having created any new container, or really after installing any new operating system, is to be sure to update the repositories with an apt update. And then I like to go ahead and take all of the updates, so you can say ampersand apt upgrade. And then in order not to have to answer the question that you may be asked on whether you want those upgrades installed, I do a -y, and it goes ahead and does all of that in one step. And here it says that it has 3 packages that can be upgraded, but it didn't upgrade any of them because it says that these packages are kept back. If there's a dependency problem, sometimes it'll wait for future updates before it will take some of the older updates, and that's why you'll see some of your packages that may occasionally be indicated as being kept back. Now that the updates are installed, there's a few things we want to do to our new system here, and I always like to install OpenSSH server, so I'm going to do an apt install OpenSSH-server, and that'll give me a way to SSH into the system later on instead of having to always go back to the Incus console to connect to the system. There are a couple more utilities or tools that I like to install on a new system. And so I'm going to do an apt install on net-tools because I like the format of how it displays the network devices. And then it also has some other additional commands. I'm also going to install btop. So if you want to install multiple tools, simply leave a space between their names. And I want to install curl. So btop is a program that allows you to look at your current resource utilization, and it's a very nice command line tool that we'll look at in a minute. And then the curl tool is something that lets you download and execute things remotely from a web page. So I go ahead and install those and say yes, I want to continue. When you create an Incus container from an image, you do get a user account, and the user account name is Ubuntu, but it doesn't have any password associated with it. So one of the things that I like to do is I like to do a add user, and I'm going to add a user named Scott so that I will have a user account that I have a username and password to that I can log in. And I'm also going to grant Scott the sudo privilege in order for him to perform sudo operations or privileged operations. So I do that by usermod-a capital G sudo Scott, and we've now put Scott into the sudo group. Now here I can do an if config, and I can see that this is running at 172.16.1.169. I can go ahead and log off of this. And in fact, I'll even go ahead and log off my Incus server. And now I'm back to my desktop, and I can do an SSH over to 172.16.1.169, which is the address for my Pi-hole. I say yes that I want to accept the fingerprint, and then I go ahead and type in my new password, and I'm logged in. Installing Pi-hole is exceptionally easy, and all we use is this curl script right here. So when I execute the curl script, it's going to ask for a sudo password for the Scott account, which I go ahead and type in, and then it performs the installation of Pi-hole, which really runs very quickly. The Pi-hole installer will come up with some simple questions. The first thing it says is that this installer will transform your device into a network-wide ad blocker. So we'll go ahead and hit enter, and then it's powered by your donations. Like all good open source software, I encourage you to donate to these really great projects so you can keep up their work. Your Pi-hole Incus container has a DHCP address, which means it is a dynamic address, and Pi-hole really requires a static address. If you go out to your router and assign a DHCP address reservation for the address that your Pi-hole is granted, then that address will be devoted to the Pi-hole and it will not change. So that's different for every router, so look up your router documentation and learn how to set a DHCP address reservation. And then I go ahead and say continue, and then it asks me which upstream DNS provider do you like to use. And in my case, I really recommend Cloudflare. There are others, and if you have a favorite, certainly choose it. Then I go down to OK, and then it says that it can enable third-party list. So I'll go ahead and say, yeah, go ahead and enable that third-party list. And then do you want to install the admin web interface? And of course, yes, it's not too useful unless you do have the admin interface. And then it says the web server is required for the interface. And of course, I want to install that. And would you like to enable query logging? Yes, I definitely want to log the instances where client systems are either denied or allowed access to resources. And then what would you like to do? I'd like to go ahead and show everything, and I go ahead and do a continue, and from this point it continues to the conclusion of the installation. At the end of the installation, you're once again given the reminder, if you haven't done so already, that IP address that it used for this particular system should be set to static. And then you go to the web interface by going to your address, which is 172.16.1.169/admin. And it gives you an initial web login password. And note that this web login password is not the same as the password to sign into the Incus container. So you can either make note of that password, or we can go ahead and change it. At this point, you can go ahead and hit enter, and it should complete. If you want to set your own password for your Pi-hole web interface, you can type Pi-hole -a -p, and it will go ahead and ask you for a new password. I'm going to go ahead and type in a password, and I'm going to go ahead and confirm that password. And now I have my own password for my Pi-hole web administration interface. To check for and apply new updates to the Pi-hole software, you can come back to your command prompt by SSHing into your Pi-hole instance, where I am here, and you can simply type the command pi-hole-up, and it will check to see whether there are any updates. In this particular case, since I've just finished an installation, it says that it is currently up to date. Before we go over to the Pi-hole web admin interface, I want to go ahead and type the btop command, and btop will of course list all of the components of the operating system that's running, and we're talking about the operating system here for this Pi-hole instance. And as you notice, it's only using 81 megabytes of memory, and so this thing is extremely small and extremely lean. Just as an example to show you Pi-hole under load, I have my Pi-hole main, which is on my main LAN, and it is using 209 megabytes of memory in its container, and then Pi-hole IoT is using 143 megabytes in its container. Now these two for right now happen to be LXD containers, but they would use the identical amount of resources if they were in Incus containers. Here I am in my web browser to take a look at the Pi-hole web interface, and if I just simply go to the address of 172.16.1.169, it will just come up and tell you that it is connected to a web server, but it won't actually connect to our Pi-hole. So we want to put a /admin at the end of the address, and when we do that, you'll get a prompt down here to enter the password. So I'm entering the password that I got by doing the Pi-hole -a -p. If you didn't do that, you should have made note of the initial Pi-hole password at the end of the installation. When I hit enter here, I am now inside of my Pi-hole instance, and we have our dashboard. It says there's 0 active clients, 0 block clients. You can list all queries, and you can manage your ad list. And you can also go down to the query log and see which queries have taken place, which is a little redundant from the dashboard. We could go down here and also go into local DNS, and you can make local DNS record entries as well. But this isn't all there is to configuring Pi-hole. If we go down to the settings option in Pi-hole, you'll see that they have a number of options, and one of them is DNS. And by default, you'll remember during the installation that I chose Cloudflare as being my DNS, and so that's the one that is checked off. But that is checked off as an upstream DNS server. In order to use Pi-hole, you're going to have to go ahead and head over to your router administration interface. In my case, I'm using a Ubiquiti Unify Dream Machine Pro, and I've gone over to the settings option, the networks option, and I've chosen my main LAN, and I go down here through the list, and I have my settings set to manual, and I move further down, and further down in the list you will see that it has a DNS server listing, which will probably be checked off as auto initially, and you'll want to uncheck that and enter your own DNS entries. In my case, 172.16.1.6 is my primary Pi-hole, and I also have a backup Pi-hole, and then I go ahead and have the Cloudflare primary server and the Cloudflare secondary server. What ends up happening is that when individual clients on your network connect to your Pi-hole, inside of the Pi-hole, it will scrutinize where it's going to decide whether to go there or not. And then once it decides that the site is okay, it will relay that onto your upstream DNS servers as we had configured. If the primary Pi-hole is not accessible, and in my case, since I have a secondary and it is also not accessible, then it's going to go ahead and continue on to the Cloudflare servers. The bottom line is you always want a DNS to be available. And Pi-hole is basically a DNS that you can run locally on your network, and it performs operations to scrutinize where things are going and can decide whether or not it's going to legitimate addresses. Since I didn't want to change my Pi-hole configuration on my network, you can see here that I'm pointing to that address we just looked at, 172.16.1.6, which is set as my primary DNS server for my main LAN network. And if you look here, you can see on the Pi-hole dashboard it says that I have 48 active clients, which means that 48 different systems on my main LAN are using this instance of Pi-hole. It's performed 296,523 queries and counting. And out of those, it has blocked 9,082 queries, and it says that it's blocked 3.1% of those queries. So I have additional firewalling inside of my network, and Pi-hole is just one of the many layers that I have that controls my outbound access to resources on the internet. And then it says my ad list currently has 3,676,761 entries, which means that it's looking for these numbers of domains that have been known to be problems. When we come down here and go to query log, you'll see that there are some instances that are mentioned in green and some that are in red. The ones that are in red are the ones that have been blocked, and the ones that are in green are the ones that have been allowed through successfully. And so that's how we can watch what is going on. And as I said, Pi-hole is an extremely lean program. Now, if you have your Pi-hole installed and you have the DNS settings as we've just mentioned, you can also go into this local DNS area and you can create DNS records for things. So you can create DNS records for your various systems, and I have quite a few of them out here In fact, I've probably got 10 plus pages of locally defined addresses inside of my network, which is local DNS. And they also allow you to have local CNAME records as well. And I have a great video that talks about how to do redundant pie holes, and also another video that talks about how to do local DNS for your websites internally on your network. So in summary, in this tutorial, we created an Incus container bridge to the main LAN and installed the pie hole ad blocker. Incus containers provide a very efficient means to host applications with far less overhead than a virtual machine. And Incus is open source and promises community-supported enhancements to improve functionality and compatibility with a wide variety of Linux distributions. Watch for more tutorials demonstrating how to install self-hosted applications in Incus. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.